There was a time when a factory needed a flat machine bed, a long, accurate guideway, or a precisely cut slot, and the answer was usually the same: the planer or the shaper. These machines stood in almost every machine shop, from small repair rooms to locomotive works and heavy engineering plants. Today we are going back through industrial history to see which shapers and planers once dominated the factory floor. This countdown includes both shapers and planers, ranked by 4 factors: how widely they were used in factories, their historical influence, the scale of work they could handle, and how well they represent a major step in metal planing technology. This is the Gear Archive. Remember to like and subscribe before we begin the countdown. At number 20, we begin with the Atlas 7B. Atlas introduced its 7-inch shaper in 1938. It was not the most powerful, the heaviest, or the most accurate machine on this list. But very few machines did more to bring the principle of shaping down to the scale of the small workshop. Atlas sold the machine under its own name. Sears sold it under the Craftsman badge. In Britain it appeared as the Acorn, and in Australia it was known as the Austerlite. A small American design therefore traveled far beyond the factory where it was born. The machine had automatic cross-feed, a table with multiple T-slots, and a 4-speed drive. Early examples even lacked a front table support, a detail Atlas soon added after discovering that the table could flex under heavier cuts. It was a very real example of a product maturing in production. What kept the Atlas alive was economics. A cheap piece of high-speed steel could cut a flat, a slot, a dovetail, or a keyway, while a milling machine often needed more expensive cutters. For a repair shop or a home shop of the period, that difference mattered. The Atlas did not dominate heavy industry, but it opened the door to the shaper for thousands of machinists, and that is why it begins our list. Just above it is the South Bend 7-inch shaper. South Bend introduced its 7-inch precision bench shaper around 1950. The company was already famous for its lathes, but it sold the shaper in the same way it sold its lathes, not merely as a piece of iron, but as part of an education. The machine appeared in the 1950 catalog, and by 1954 South Bend had published How to Run a Metal Working Shaper, a manual written for operators. In the post-war years, when vocational training was expanding rapidly, literature like this helped turn the shaper into a machine that could be taught by a standard method. The earliest machines had no serial numbers and required the operator to lubricate the ram manually. By the mid-1950s, South Bend had added a pressure lubrication system and clearer numbering. The machine was small, approachable, and directly copied on the other side of the Atlantic. It ranks number 19 because South Bend's greatest influence was not cutting power. It was the way the company made the shaper part of a normal machine shop education, and that design would lead directly to the next machine on the list. Across the Atlantic, Boxford took that same idea in a British direction. Boxford introduced its 8-inch shaper in the 1950s. The early MK1 version was a modified form of the South Bend design, while the MK2 moved the motor into an enclosed underdrive stand, making the machine safer and more compact. Later, it became known as the S200. Boxford sold very successfully into schools and training institutions across Britain. There is one detail that is almost comic, but also very revealing. Many examples later appeared on the second-hand market in nearly unused condition, because cautious teachers had allowed students to do very little real work on them. But when it was used properly, the S200 did exactly what a shaper was supposed to do. It taught students how to set a tool, understand quick return motion, and produce flats, angles, slots, and keyways with a simple single-point cutter. It did not have the production pedigree of Elliot or the cutting strength of larger machines, but the Boxford was one of Britain's most successful educational shapers. Its life was spent mostly in school workshops rather than at the center of a production line, and that is why it stands here. If the Boxford was a teaching shaper, the Elliot 10M was where a small machine began to step into more serious work. The 10M developed from the Alba 1A, a design with roots in the 1930s. Alba continued producing shapers into the 1970s, and the 1A became the well-known Elliot 10M. Thousands were sold to schools, colleges, training departments, and production workshops. That was a rare range of customers. The machine had a 10-inch stroke, 4 speeds, standard automatic cross-feed, and optional vertical feed. Later versions placed the motor inside an enclosed stand and added support beneath the table, improving both safety and rigidity. What keeps the 10M alive today is not speed. It is not a fast machine, but its tooling costs almost nothing, setup is straightforward, and it can leave a fine flat surface on a casting where a small milling cutter may not be ideal. The Elliot 10M ranks number 17 because it was one of the most common small shapers ever used for both training and real work. But when production demanded greater metal removal, a 10-inch stroke quickly became a limit. Elliot did not stop with the 10M. Through the Alba and Invicta names, the company sold an entire family of larger shapers with 14, 18, 24, and even 30-inch strokes. The Invicta Series M already existed before the Second World War. In the early 1950s, the machines began carrying the Elliot/Invicta badge, and by the end of the decade, the Elliot name had become dominant. The larger models used multi-speed table feed gearboxes, instantaneous reverse, and the ability to change feed without stopping the drive. The 24S is the point where a shaper no longer looks like something meant to sit beside a bench. With a 24-inch stroke, a large table, tooling of around 1 inch, and a motor of several horsepower, it became a genuine production machine for jigs, castings, and general engineering. It also helped put the Elliot name into many post-war British factories. The 24S took the formula of the 10M into production size without changing its mechanical character, but the American machines above it were built heavier and served in harsher industrial environments. Next, we come to a machine from Hendey. Hendey had been building shapers since the late 19th century. Its historical product range included crank shapers and traverse shapers from 15 inches to more than 30 inches. During the Second World War, Hendey expanded rapidly with American demand for machine tools. But after the war, the company's story moved in the opposite direction. In 1952, control passed to Frederick W. Richmond, who later sold off product lines, land, and factory assets piece by piece. Barber Coleman bought the Hendey lathe and shaper lines. In a 1955 meeting to decide what was worth keeping, the company still chose to continue the 12-inch shaper and the 16 to 20-inch shaper group. That was a strong endorsement. When a company is being dismantled, weak product lines usually disappear first. Complete production did not continue forever, but parts were made for years afterward. The Hendey represents the American shaper before and during the war. Heavy, simple, and valuable enough to survive even after Hendey itself no longer existed in its old form. Gould and Eberhardt of Newark was famous for gear machinery, but its shapers were also a very real part of American industry. In 1941, an official price catalog showed the company selling tool room, industrial, and universal shapers from 14 to 36 inches. A 24-inch industrial model weighed around 6,900 pounds, while the universal table version was heavier still. By 1942, the War Production Board was setting prices for the company's 24, 28, and 32-inch industrial shapers. In the same year, a subcontract order for 150 universal tables for Gould and Eberhardt shapers was recorded in the Federal Register. This was no longer a tool room curiosity. It was part of the wartime machine tool economy. Another record of equipment purchased for Japan before the war listed multiple Gould and Eberhardt 16 and 24-inch shapers, along with a 60-inch by 30-foot double-housing planer. Even today, 24-inch Gould and Eberhardt machines still appear on the industrial market, weighing more than 3 tons. Gould and Eberhardt was one of the clearest examples of an American production shaper during the war years. But Cincinnati ranks above it because its influence reached more directly into the evolution of the shaper itself. Now we return to one of America's great industrial centers, Cincinnati. Cincinnati Incorporated is known today for press brakes, shears, and laser equipment. But the company began in 1898 as the Cincinnati Shaper Company. Its first products were metal-cutting shapers for the growing industries of Ohio, including local machinists and gun barrel manufacturers. As early as 1900, one of the company's engineers patented an automatic downfeed mechanism. In 1924, Robert Hazelton patented a shaper with change-speed gearing and controls gathered into a more convenient position for the operator. By the early 20th century, factory planning literature was already using the Cincinnati Shaper Company as a standard when calculating horsepower requirements for 16, 20, and 24-inch shapers. A 24-inch back-geared machine could require around 7 horsepower under heavy load. As fabrication equipment became more important, Cincinnati changed direction and survived into the present, while the shaper almost vanished from the market. It ranks number 13 because it was one of the most influential production shapers of the early 20th century, and because it gave birth to a company that still exists more than 125 years later. Rockford Machine Tool Company approached the shaper from a different direction. From the 1930s onward, Rockford increasingly specialized in hydraulically powered ram-type shapers, planers, slotters, and other reciprocating machines. By the 1956 catalog, the hydraulic shaper was clearly part of the company's product line. A 1950 Rockford patent described the problem that hydraulic drive was intended to solve. On a crank shaper, the force delivered to the ram changes with the position of the crank. A hydraulic system can provide steadier force during the cutting stroke and smoother speed adjustment. For roughing work, the operator was no longer completely locked into the motion profile of a crank. Cutting and return strokes could be adjusted more flexibly. Hydraulic drive traded the simplicity of gears for pumps, valves, and seals. When new, it was a step forward. When old, oil leaks became part of ownership. Rockford represents the largest modernization of the American shaper, replacing the traditional crank mechanism with hydraulics. But in Germany, high-speed shapers reached a much broader industrial presence through the next name. Klopp began building machines in Solingen in 1910. After the First World War, the company moved strongly into Schnellhobler, or high-speed shapers, and local historical sources state that Klopp eventually produced more of these machines than any other company in the world. After the Second World War, Germany was restricted from building machine tools. When the ban was lifted, the first shapers Klopp produced again in 1948 were built for the Deutsche Bundesbahn. Railway repair required flat surfaces, keyways, and guides of many different kinds, and the shaper was extremely useful for that work. The Klopp 550 weighed more than a ton. The 650H, 850H, and 1000H models moved to hydraulic drive. In 1960, during the company's 50th anniversary, Klopp even found a high-speed shaper built in 1918 that was still working, and exchanged it with its owner for a new machine. Few companies were so closely identified with the shaper. Klopp was almost the national machine of this type in Germany, but the next position shows just how large a shaper could become before it started to blur into a planer. In 1928, the High Commissioner of New Zealand traveled to Halifax to inspect a machine being built by the Butler Machine Tool Company for the country's railway system. It was described as a 60-inch stroke draw-cut shaper. The machine weighed about 40 tons. This was no longer a small shaper with a vise on a table. The main stroke bar was a steel forging about 10 inches square. The work table was roughly 12 feet square. The machine could plane, shape, bore, mill, and drill parts such as locomotive cylinders. It was part of New Zealand's program to build new workshops for locomotive, carriage, and wagon construction. The machines ordered from Halifax alone made up a significant portion of the early equipment order. Butler had pushed the concept of the shaper to the point where the boundary between shaper, borer, and planer began to blur. It ranks number 10 because it may be the most excessive shaper on this list, a 40-ton machine built for railway production. But from the next position onward, instead of making the ram larger, industry took the opposite approach: keep the tool relatively still and move the workpiece itself. The Whitworth planer of 1842, preserved in the Science Museum, is one of the oldest machines on this entire list. Its working history fits perfectly with the role of the planer. It once stood at the London and Northwestern Railway Works at Crewe, where it is believed to have been used to plane axle boxes or horn blocks for locomotives. Joseph Whitworth wanted to improve one of the planer's greatest weaknesses, the wasted return stroke. He developed a tool holder that could rotate 180 degrees, allowing the tool to cut when the table moved forward and when it returned. In the shop, this mechanism was known as the Jim Crow. The idea was clever, but reality was less forgiving. Bearing wear made the two-direction cut uneven, and the surviving machine eventually had its special tool holder replaced with a conventional clapper box. The machine itself was later replaced at the railway works by a larger planer, because the newer machine could work on 4 axle boxes at once instead of 1. The Whitworth ranks number 9 because it helped lay the foundation for precision machine building. But its own history shows what factories always wanted: something larger, faster, and capable of more output. At number 8 is a machine the world wanted to copy. In 1862, William Sellers developed a planer using rack and pinion drive with worm and spiral gearing to produce smoother table motion. The machine quickly became one of the designs most closely associated with his name. Sellers also stripped away much of the decorative style common in 19th century machine tools, moving toward forms dictated by function and toward the machine gray appearance that later became so common. At the Centennial Exhibition in Philadelphia in 1876, Sellers was one of the most important machine tool exhibitors. A contemporary review stated that his designs had been used as patterns by builders in many countries. The durability of Sellers planers was also recorded very clearly. A report on the machine tool trade in Europe in the early 20th century found a Sellers planer installed in 1867 that the shop still described as working well many decades later. Sellers helped establish the design language of the modern American machine tool. But the next builders turned the planer from an excellent individual product into a production machine with multiple tools working at once. In 1887, American machinist described Bement-Miles and Company planers with capacities from 4 feet upward, powerful enough to take 4 heavy cuts at the same time. That was how the planer fought its greatest weakness, the slow single-point tool. If the table had to carry tons of iron beneath the crossrail, then the obvious answer was to mount several tool heads and machine multiple surfaces in the same stroke. The Bement-Miles heads had independent feeds, allowing them to work in different directions without requiring the operator to reset the entire machine. The company's machines were exported. A report on a factory in Belgium listed Bement-Miles planers working alongside machines from Gray and American Tool Works. At the Paris Exposition of 1900, Bement-Miles received a gold medal in the machine tool group. Only 1 year before that, the company had become part of the Niles-Bement-Pond consolidation. Bement-Miles represents late 19th century production planing in mature form, multiple tools, heavy cuts, and an export market. That is why it stands here. But a New England rival above it had enough influence for its name to become part of that same industrial consolidation. Lucius W. Pond began his machine tool business in Worcester in the mid-19th century. By 1874, the catalog listed lathes, planers, boring mills, drills, and gear cutters in a product line serving machinists and railroads. Pond planers appeared in serious performance tests in the late 19th century. One 48-inch machine doing regular shop work was recorded cutting about 15 pounds of cast steel per hour. Another 36-inch Pond machine was tested for horsepower under load. In 1898, Manning, Maxwell, and Moore received an order for a 72-inch Pond planer for the Davis-Egan Company, exactly the type of customer that built large machine tools itself. An old Pond planer still survives today in a historic machine shop in the United States, while the Pond Machine Tool Company itself came under Niles' control in 1898 and became one of the 4 pillars that formed Niles-Bement-Pond the following year. Pond ranks number 6 because its planers appeared at the exact moment when railways, steam machinery, and heavy machine tool building were expanding rapidly. But at number 5, the planer was no longer treated merely as a machine. It became part of a science of production time. The Cincinnati Planer Company was founded in 1898, born from the enormous machine tool building ecosystem of Cincinnati. By 1912, the company was not simply selling machines. It published a treatise on planers of more than 100 pages, explaining how flat surfaces could be produced more economically. One example in the book shows a planer machining both horizontal and vertical surfaces on steam locomotive cylinder housings. The company even issued its own slide rule for calculating cutting time on planers. An operator or planner could enter cutting speed, return speed, feed, and job dimensions to estimate production time. This was Frederick Taylor walking directly into the machine shop. Cincinnati Planer also continued to patent hydraulic feed, traverse, and table stop mechanisms in later decades, all aimed at reducing idle time and improving control over ever larger machines. This was the moment when a planer was no longer judged only by whether it could create a flat surface. It was judged by cost per job and minutes per stroke. But the next position belongs to a company we have mentioned in a previous video, one built from the ground up to manufacture planers larger than almost anything ordinary, the G.A. Gray Company. In 1925, the G.A. Gray Company opened a new plant in Cincinnati, advertised as the last word in machine tool plants. This nearly $1 million factory was designed around the construction of planers. Its bays had 30-ton bridge cranes, capable of lifting single castings 40 feet long and weighing up to 25 tons. One advertisement placed Gray's smallest standard planer, a 24-inch by 5-foot machine, directly on the table of one of the company's largest maximum service planers, simply to show the difference in scale. Gray did not sell only in the United States. A report on the machine tool trade in Belgium stated that European makers genuinely feared competition from small, high-grade Gray planers, because American builders could sell them for less than a European firm could manufacture them locally. The same report listed numerous Gray machines running in a Belgian shop. This was dominance through both engineering and economics. Very few planer builders ever had a factory so clearly designed around casting, lifting, and finishing giant machines. Unfortunately, that same commitment would eventually contribute to its decline. You can find the full story of G.A. Gray's rise and fall in another video on our channel. The final three positions are tied even more directly to locomotives, armaments, and the heavy industry of entire nations. The first machine in our top three comes from Craven Brothers. Craven Brothers was founded in Salford in 1853 to make machine tools for the locomotive industry. The company later expanded into armaments, cranes, and heavy machine tools. In 1900, Craven moved to Vauxhall Works in Reddish, a site of about 25 acres. During both World Wars, the company was placed under government control because of its industrial importance. After the First World War, export business, especially with Russia, helped the firm survive a difficult period. Planers were a core part of that product line. One Craven planer recorded in recent times had a working capacity of about 6.1 meters by 2.3 meters and weighed roughly 38 tons. Surviving order books from 1929 to 1970 contain specifications and quotations for customers at home and abroad. This was the kind of machine purchased as infrastructure. Once installed, it could remain in a factory for decades. Craven ranks number 3 because its machines served the three industries that made the planer king of the heavy shop: locomotives, armaments, and heavy engineering. Above Craven stands a machine tool empire. Niles-Bement-Pond was created in 1899 through the merger of Niles Tool Works, Bement-Miles, Pond Machine Tool Company, and Philadelphia Engineering Works. The group later acquired Pratt & Whitney and other builders. At its peak, the system had multiple plants and more than 7,000 employees. One historical source described it as the largest machine tool company in the world at the time. The important point is that three names in the merger, Bement, Pond, and Niles, already had deep experience in heavy machine tools before coming under one roof. Niles-Bement-Pond did not have to learn planer building from the beginning. It gathered an entire generation of American planer engineering into one organization. The company's 1920 catalog is filled with phrases such as locomotive frame, gun barrel, planer, boring and turning mill, and heavy tool works. The Smithsonian still preserves an archival photograph of a Niles-Bement-Pond rotary planer. On the used machine market, NBP planer mills tens of feet long still appear from time to time. But even in early 20th century literature, milling machines were beginning to be promoted as faster for many jobs once done by planers. Niles-Bement-Pond loses only to one company that made reciprocating machine tools a national specialty and exported them into almost every major industrial economy in the world. And our champion is a Butler. Not because a single Butler was necessarily the largest planer ever built, but because the history of the company almost matches the life cycle of the technology itself, entering the field when reciprocating machine tools ruled, exporting them around the world, and then moving into milling as the planer age came to an end. The Butler Machine Tool Company was founded by James Ryder Butler in Halifax in 1868. At first, the company made looms. Later, it turned to machine tools. After the First World War, major British builders reached specialization agreements to reduce wasteful competition. Butler chose a very specific field: reciprocating machine tools, planers, shapers, slotters. Between the wars, Butler became the preeminent British manufacturer of these machines and exported to every industrialized country. During the Second World War and the re-equipment period that followed, its order books remained full. Specific machines show the company's scale. One open-sided Butler planer was recorded with a capacity of about 8.3 meters by 2.2 meters and a weight of around 75 tons. A 40-ton Butler shaper already appeared at number 10. In other words, the same company could serve everything from tool room reciprocating work to castings that were almost part of the factory itself. And then Butler also witnessed the death of the planer. By the 1960s, the company acknowledged that multi-point milling cutters had overtaken the single-point planing tool in productivity. Production shifted toward plano millers with 70 to 100 horsepower heads, and the Elga mill became an important new product. If one name must represent the age when factories shook to the rhythm of the table moving forward and back, it is difficult to choose a better one than Butler. Seen from 2026, shapers and planers can look like machines designed to waste time. One cutting stroke, one return stroke, one single-point tool. Meanwhile, a milling cutter has many teeth and cuts almost continuously. But that is the view from after milling had already won. The end was visible surprisingly early. In 1887, American Machinist published comparisons showing that milling could be cheaper than planing on production work. Eventually, that prediction became reality. Even so, walk through machine shops today and you may still find a small shaper in a corner, or a massive old planer occupying a whole section of the floor, like a machine from G.A. Gray. The golden age has passed, but the machines have not entirely vanished, and perhaps that is the best reason to remember them. Have you ever operated any of the shapers or planers on this list, or did your factory have another name we missed? Tell us in the comments below, and if you enjoy stories about the machines that shaped the industrial world, remember to subscribe to the Gear Archive. Thank you for watching, and we will see you in the next episode.